Hello, guys. I just want to go over the notes real quick once again and give you or assign you more homework problems to practice on geometric. Only one person did the homework. So let's go over it kind of quick, the notes part of it. And, I'll look at a couple homework problems. Try to make this as quick as we can. Understand we did probability distribution, expected value on those things. And we'll review a little bit on Thursday with them. And then we jumped into binomial probability uh, with random variables. And we did the mathematics with that. And now we've got a geometric setting or a geometric random variable and geometric probability. The big difference between that binomial and geometric, binomial says this: I've got five fixed trials, and what's the probability that I get three out of those five? Whereas geometric says, how many trials does it take for me to get a success? So the wording of it kind of helps us to know if they're talking about binomial probability or geometric probability. And again, the more that you practice it, the more that you try it, the better that you're going to get with it. Okay. All right. So how many bottle flips? If I want to go viral, a talent show scheduled to take place this afternoon. Um, he tells his friends the probability of success landing the water bottle right side up is 20%. Assume that each water bottle flip is independent. That's big because that's a scenario in order to determine if it's a binomial setting and if I can use my calculator in a proper way. If I flip the bottle 10 times, how many do you expect to land right side? In other words, give me the mean expected value right there. Expected value. Give me the mean. Okay. Well, we learned in a binomial setting, because this is binary, right? I can land it right side up or not. It's independent because they told me there is a number that will be fixed. They didn't tell me up here, fixed number of trials. And then the probability of each trial remains the same. So this acrostic bends actually, gives us a binomial setting. Uh, so, oh, 10 times, yeah. So we got the number of trials fixed. Out of 10 times, how many do I expect? Well, if it's 20% for one of them, multiply that times 10, and we learn this expected value for binomial, or the mean being the number of trials times the probability. No big deal. Okay. What's the probability of two flips? Exactly two flips. This is the difference between binomial PDF and binomial CDF. Okay, and we learned that a little bit as well. Okay, if he makes exact, well, out of 10 tries, I want two to be a success, and we know how to put that into our calculator. So right now, this is a binomial situation. Okay, what's the probability that he makes less than two flips? Now, that's not a PDF, that's a CDF. Okay. So less than two flips does not include the number two. So I really want one and zero. If I want to do it out long ways, that's what it would look like. Zero successes, 10 failures, plus one success, nine failures gives me this. Or we can put it into our calculator, and we know how to do that already. Last question. What do we do when we have greater than? Well, this is a scenario that says greater than two or more. Flip, that's greater than. Remember, our calculator can't necessarily calculate that as well. So our trick is we're going to do one minus what they say. Well, out of 10, out of 10, uh, I can do two or greater, which means, add them all up, or one minus zero and one. Well, we already did zero and one. There it is right there. One minus that would give me about a 62% chance. That's binomial probability. We got trials. Out of this many trials, what's the probability of whatever success? That's how you word that. Now we're talking about geometric. Okay. Same thing. After the first 10 flips, he wants to do more. Teacher's getting annoyed, tells him to stop flipping once the bottle lands right side up. So question 5, 6, 7, and 8 kind of build this formula here. All right. What's the probability he does it on the first try? What's the probability that he fails on the first and then gets it on the second? So we're kind of building up. All right. So the more that I actually do this, we're going to find that if we were to graph it, histogram kind of way, our distribution is going to be skewed to the right. It's not going to be, it's not going to be uniform straight across, not skewed to the left, right? Or it's not necessarily going to even be normal. It's going to be skewed, right? Find the probability he fails the first three. Well, what's the fail? 80, fail, 80, fail, 80, success, 20. When we multiply all that together, right, we're going to get the probability, of what they're asking for. So then we can put it into a distribution, okay? We can basically put it into a distribution, which is a geometric sequence. Geometric, we're multiplying, right? And that's how we get it. The probability, well, that was already given to us, times 0.8, which is a failure, right? Failure, I fail every single time until I reach a success, okay? So what's the probability he gets it on the 10th try? Well, that would mean I would have to fail 9 times, multiply that by succession. That's kind of going to lead us into the geometric formula right there. Okay. The mean or the average of geometric formula, 1 divided by the probability of success, right? And that's what it is right there. Okay. All right. And so that leads us into our learning targets. What is geometric distribution? Well, it's the same thing as binomial. The only thing that's different is how many trials does it take to get a success? Binomial says, you know what, I got a set amount or fixed amount of trials. What's the probability of getting a certain number out of those fixed number, right? Geometric formula is given to us here. The shape is skewed right. The mean or average expected value is found by this. It's given to you on your AP exam. And the standard deviation is given here, right? Square root of 1 minus success or failure divided by the success again. And that's how we do it. So let's look at some of your homework problems. Okay. We'll do 1 through 4, and I'm going to assign you different ones again. So you got these, and you need to do the next one. Again, I know what certain people are doing in the class. Guys, you're highlighting it, you're right clicking it, and you're just saying search for the answer. Okay, well, that might work on here. It's not going to work on paper. All right. So please make sure you're understanding what you're supposed to be doing. We're trying to prepare you for the AP exam, which did have geometric probability in it. Certain board game, player rolls 2 dice, okay, 1 through 6 on each dice, until a player rolls double. The value on each die is the same, 1 through 6. Probability of rolling doubles. What's a double? One dice has 1, the other has 1. 2, 2, 3, 3, 4, 4. Those are doubles. How many doubles are there out of 36 rolls? There's actually 6 ways you can get that. 6 divided by 36, that's where they get the 1/6 at. Okay. So we just reduce it to 1/6 scenario, right? What's the probability that it takes 3 rolls until the player rolls doubles? Well, let's find out what we're talking about. Is this binary? Can I Can I succeed? Well, yeah, I can roll a double, or I might not be able to roll a double. All right, so it's binary. Is it independent? Yeah. Well, one dice does not have, or one rolling of two dice, it's not dependent upon another dice. So we're going to assume this is independent. Well, not assume, we're going to know it. It's independent. Uh, is this geometric or is this binomial? Well, do we have a set number of rolls? Well, it looks like here, what's the probability that it takes three rolls? Well, I'm not really setting a fixed amount. Out of 10 rolls, what's the probability I get three of them? You don't see that here. What's the probability of failing, failing until I get a success? That's what it's saying here. This is a geometric statement or question. So we're going to set it up in such a way. We're going to say if it takes three rolls, that means the first two have to fail. Well, if it's 1/6 succession, what would it be to fail? Well, 5 out of 6 would fail. So I need 5 out of 6, another 5 out of 6, and then on the third roll, it needs to succeed, which is 1 out of 6. So if you pulled up your calculator and put all that in, you get a probability. But they just want to know, do you know how to put it in? Well, right here it says 1/6 to the third power. That means I'm going to succeed 3 times in a row. That's not what we're looking for. What's the probability it takes three rolls, right? Fail, fail, succeed. Okay. 5/6. Well, that's the same way as saying I'm going to fail 3 times in a row. That's not what we're looking for. This one says here, I'm going to succeed 1 time, right? And fail 3 times. Well, that's 4 rolls. That's not what we're looking for either, right? This one says here, I'm going to succeed 1 time and fail 2 times. This is the one we're looking for right here. Okay. This one at the bottom. E says I'm gonna fail 1 time, I'm gonna succeed the next two. D should be our final answer here. Let me pull up the answer key, see if we're right. Yeah, we're good here. And on the bottom, this is how you do it. The probability of X equaling three, three exactly, okay, would look like that. And this would be binomial PDF if we were to put it in our calculator, okay? Very good, very good, okay? Let's go on to the next one here. Certain computer chip company as a machine makes a large number of computer chips. Computer chips that's produced, 3% are defective, which means 97 of them are good. Miriam will randomly select computer chips from the machine to inspect. Probability that the first computer chip finds is the sixth computer, first defective, all right, chip that she finds is the sixth one that she inspects. So she goes through 6 of them. What's the probability that the first 5 are good? The sixth one is not. All right. So I'm looking for something that, in this case here, it's kind of a play on words. Defective is kind of a negative term, which might mean fail, but I'm actually looking for the fail. So the one that I'm not looking for is the succession, right? Hopefully that makes sense to you a little bit. The way that they word this is a little bit different. So I'm really looking for 5 of them, right? 5 of them that are not defective. I'm looking for 97% 5 times, and the sixth one is 3%. That's what I'm looking for. So this one here says the first 5 are defective, one of them is good, right? This one says uh, the first 6 of them are defective, one minus that. So what they're saying is, seem like to me, I'd have to come back to that one. I'd have to write it down just a little bit. 1 minus all 6 of them are bad, right? 1 minus all 6 of them are bad. I don't like this choice here. I think answer C would be a little bit better. The first 5 are good, and the last one is bad. I think I like that one the best. These here that's got 1 minus, a little bit confusing. And then D says that all 6 of them are good that I actually find. I think C is a little bit better. Yeah. Let's see. I want to know. Yeah. Once again, the formula for geometric. Oh, I see. Okay. So 1 minus all of the failure, right? And the number of times that I'm looking for minus 1 times, uh, what it is I was looking for the defectives, right? So if X equals 6, I want to see what's wrong with these. I want to see what's wrong with these here. Yeah. That's right. That's the probability that at least one of them, right, will be found as non-defective, right? This one here, 1 minus, which is at least one of them would be found defective. Yeah. Anytime you see 1 minus, that's at least. Yeah. There we go. Good. All right. So hopefully you kind of get the understanding of the difference of binomial and geometric. Okay. And I'm gonna assign probably 3 or 4 more problems for you guys to do tomorrow. Okay. 21% of customers purchase extended warranty. Customer wants to buy eligible items. Are chosen at random one at a time until one is found. There it is. That's that's a really good statement. Until one is found, there's not a fixed number of trials, so automatically I can almost say I'm dealing with a geometric probability here until one is found. Okay. They're independent, which means I'm allowed to use a geometric scenario here, which is following as close as probability. Everything greater than 3 takes, that is the probability. Takes more than 3 customers to find eligible item to find one who purchased the extended warranty there. Well, wouldn't that just be 1 minus, right? X as being 2. So I think we can throw, okay, so they're giving us probabilities here. Okay, so I'm going to use my calculator. Last videos, you guys have not been able to see it. So I'm going to work it out here. This is a geometric scenario. So I go second distribution on my calculator. All right. We're talking cumulative because it's not saying X equals 3. X is greater than 3. So we're going to put in the geometric CDF. I'm going to put in first 1 minus that. 1 minus, because remember, my calculator doesn't do greater than, so I've got to do less than. Second distribution. It's a geometric scenario. And in my geometric scenario, I put, let's see, probability of success, comma, and then everything less than 2, right? Everything less than 2, because it can't equal 3. So, it actually can equal 3, can it? So 3 or less, because he wants everything greater than 3. I think that's right. I think that is right there. I think it was 493. Let's check our answer. Okay, there we go. And this is the way that you want to do it. All right, so if it said, I want to find the probability of X, which is our random variable, being greater than 3, not equal to 3, greater than 3, which means 4 or more, right? Or if you want to, think about continuous, 3.1 or more, 3.2 or more, right? So that would mean 1 minus exactly 3 or less, which is right here, okay? Probability of success here multiplied with uh, the failure. That's that plus 0 plus 1 plus 2, which is everything that'll be less than 3. Yeah, 493 easily in our calculator. Easily in our calculator. And again, ask me questions if you need help on the calculator part. Difference between binomial and geometric. Hopefully you got it. Okay. Last one, guys, I'll let you go. Of all the fish in a certain river, 20% are salmon once a year. Fishing license allows them to catch up to 8 fish. Assume each, which of the following rivers are problem, need to catch 8 fish to get the first salmon. Okay. So the need to get, well, that's what I'm looking for. So the probability of needing to catch 8 to get the first salmon. So I need to fail how many times? 7 and get 1 correct. Okay. So failing, well, 20% is succeeding, 80% is failing, right? It looks like D is right. This one here says I want to succeed 7 times. I want to find 7 salmon, and one of them's not going to be a salmon. D should be correct. There we go. And that's straightforward. That is straightforward. All right. Again, if we want to put in our calculator, it doesn't ask us to put in probability or get a percentage, get a decimal on that, but that's it. All right, guys, that's it for today. I'm going to give you a list of um practice problems that I want you guys to do on your own. Again, please don't just grab the AI or copy and cheat. Some of you guys haven't even taken down the notes, and you already got 100 on the homework. Okay, it's going to hurt you on Friday. Okay, so don't do that. Try your best on these. Work out the calculations, and any questions, please let me know. All right, guys. Thank you guys so much.